Hello and welcome to PA Academy. So in this video we are going to be looking at differential work done. So that means we're going to be looking at how to calculate the differential work done. So this is a topic under electric field intensity. Alright, so now let's get started. So when we are asked to calculate the differential work done, so let me start by giving the formula. It's always written like this. So differential work done, so I hope you can see that, is equals to minus Q E bar multiplied by, so I'll give a dl small l. Okay, so that's the representation of the formula for it. So let me give the meaning of every other thing there. So the Q that we are having here is for the charge in coulombs. While the E is the electric field intensity that's V over M, that's the unit. And then what else? So the AL that we are having there is the unit vector. So when we are going to do an example shortly, so the example will give us more understanding on every of these and how to apply them. So why this is the change in distance, so the unit is in M. Okay, so what we want to do now is we are going to look at one example where we are going to be applying this formula to see how we can calculate the differential work done. All right, so this is the example. So let's look at it. It says given the electric field E is equals to 1 over z square into bracket 8xyz, then the coordinate az plus 4x square z along ay, then minus 4x square y along az, and then so you can see that's the unit there, v over m. It said find the differential amount of work done. So this is what we are looking for, the differential amount of work done in moving a 8 nanocoulombs charge a distance of 3 micrometer starting at A. So this is at A, the point A is 2 minus 2, 3, and proceeding in the direction. This is our value for AL. So now let's use this example to calculate the differential work done. Okay, so again, let's write out the formula for differential work done, which is this. So we know that our differential work done is equals to, which is dw is equals to minus Q E multiplied by AL and then DL. Okay, so now let's bring out, so from all the questions, from everything that is being said here, so let's bring out the important thing. So we have our Q from the question 8 nanocoulombs, which is 8 times 10 raised to power minus 9. So let's note that. So we're also giving our distance, that's the change in distance dl, to be this. So you can say a change in distance dl, that's 3 micrometer. So that is 3 times 10 raised to power minus 6. Okay, so what else? Then we are giving our E, electric field intensity, to be 1 over z square into brackets. So this is it here, 8xyz ax plus 4x squared z along ay minus 4x squared y az. So let's see. So what other so the other thing that is needed is the dl. So if you look at the question, it is two parts. We have the I and the II. Okay, so we also have, let's call point A. So we are given point A at the following points: 2, minus 2, and then 3. Okay, so now let's start putting them together. So the first one we are going to be solving is the A part, but before we use the A part, there's something we also need to do. So we are given point A, which is, so this is where our X, our Y, and Z. So what we do is, to make our work much more easier, we're going to put in the value of X, Y, Z into our electric field intensity. Exactly. So in doing that, we can make our work much more easier, although you might find some solution or some examples that they are going to solve it first before they start to substitute their value, but I like to do it first. So that means our E will be 1 over Z square, and our Z is 3, so that will be 3 squared, that will be 9. So let's just write that directly. Multiply by 8 into brackets. So X, Y, Z, that will be 2 times minus 2 times 3 AX plus, so 4 times, now X squared Z, so X squared Z, that will be 2 raised to power 2, that will be 4, and then our Z is 3 times 3 AY minus 4 times, so X squared Y, so that will be 2 raised to power 2, and then our Y is times minus 2 AZ. Very good. Okay, so this we are going to be having 1 over 9. So 8 times 2 times minus 2 times 3. So if you do that, you're going to be getting minus 96. Then AX. Then we're having 4 times 4, 16. Then 16 times 3, that will give us 48. So plus 48 AY. And then here we are having 4 times 2 is power 2 is 4. 4 times 4, 16. 16 times 2, minus, that's minus 32. Then if you minus it with this minus outside, you're going to be having plus 32 AZ. Okay, all right. So that means our E will then be, so let's just use this 1 over 9, this 1 over 9 outside to open the bracket. So that with that we are going to be having minus 96 over 9 AX plus 48 over 9 AY plus 32 over 9 AZ. Alright, so now let's take note of this, of what we are having here. So this is not our final answer. So this is what we are going to be using for E. Right, so now let's go back to the formula again. So since we already know our E and our Q is 8 times 10 raised to power minus 9 right here. So let's put that together. So that means let's get our QE. So let me say calculating for QE. Or let's put negative ones. So calculating for minus QE. So minus QE will be equals to, so what's our Q? Our Q is 8 times 10 raised to power minus 9. So that will be minus 8 times 10 raised to power minus 9. So multiply by minus 96 over 6 AX plus 48 over 9 AY plus 32 over 9 AZ. So let's just take note of this. So with what we've done now, we can now go ahead and solve the first part of the question, which is the I part. Exactly, because like I said, doing like this will make it much more easier. We've gotten our E. This E that we've got in the electric field intensity, we are going to use it for the I and the II. Exactly, and this QE is the same value we are going to use for it when we are dealing with question I and question II. So now that we've gotten it, you can now solve the I part. So for the first part, we are given that the value, this is the value for our AL. So let's let's go ahead and calculate our, so from the formula, from this formula, let's go and multiply AL and DL. Okay, so our AL multiplied by DL will be, so let's see, this is our AL, so this is our AL here. So let me put that in square bracket. So that's minus 6 over 7 AX plus 3 over 7 AY, and so plus 2 over 7 AZ plus 2 over 7 AZ. So multiply by DL. So again, our DL, it was given in the question. This is it, 3 microcoulomb. That's 3 times 10 raised to the power minus 6 times 3 times 10 raised to the power minus 6. Very good. So now let's use this minus 3 times 10 raised to the power minus 6. Or let's just use only the 3 to multiply everything that is inside this square bracket. So with that, we are going to be having minus 6 over 7 times 3, minus 6 over 7 times 3, so that will give us minus 18 over 7 AX plus 3 over 7 times 3, so that will give us 9 over 7 AY plus 2 over 7 times 3, that will give us 6 over 7 AZ. Then don't forget times 10 raised to the power minus 6. Okay, so if you are finding value in the video, please give the video a thumbs up. So now we can go ahead and calculate our differential work done, which is dW. And remember that the formula for dW, again, let's go back, is minus QE multiplied by ALDL. So we've already written out our minus QE, which is this. So this is our minus QE. So let's go ahead and write it out. So we're writing this out. So that's minus 8 times 10 raised to the power minus 9, open square brackets. So minus 96 over 9. So everything here. Minus 96 over 9 AX plus 48 over 9 AY plus 32 over 9 AZ. So that is it for our minus QE. So the next one is ALDL, which is this ALDL. So we've also calculated that our ALDL, this is it here. So we are going to bring it next to it, times minus, so let me just write it here. So minus 18 over 7 AX plus 9 over 7 AY. So let me continue on another line. Plus 6 over 7 AZ, close bracket, times 10 raised to the power minus 6. Okay, so now to simplify this better, so I'm changing my pen color so that you can know when I'm starting a new line. So our dW is, so what we are going to do now is let's multiply this minus 8 times 10 raised to the power minus 9 with 10 raised to the power minus 6. So if we should do that, we are going to be having, so that will be minus 8 times 10 raised to the power minus 9 times 10 raised to the power minus 6. And from indices, we can have this 10 raised to the power minus 9 times 10 raised to the power minus 6. We can bring it together to become, the power will add up, that will be minus 15. So let's do that to make our work easier. So with this, we are going to be having 8 times 10 raised to the power minus 15. Exactly. So what I did was multiply this and this. Alright, so the next thing is, if you look at what we're having here, also this bracket, everything in this bracket is also multiplying what we have in this bracket. So if you have been following on the previous video in this series, you see that we can also multiply this because they have the same coordinate ax and ax, exactly. So we can multiply them together. The same thing with this. Okay, so let's do that first. So minus 96 over 9 multiplied by minus 18 over 7. So if we should multiply that, we are going to be getting minus 27.43. Now this time around, it won't have this. This ax will no longer be there. So if you remember, or if you remember what when we did the calculation on when we covered gradient and divergence of a vector, or a vector and scalar function, so you understand what I'm saying. So once you multiply this, just like the product of a vector function, exactly. So it will no longer be there. So then plus, so 48 over 9, so that means 48 over 9 multiplied by 9 over 7. So if you should do this, it will give you, you get 6.86, then plus, so the next one is 32 over 9, which is this, multiplied by 6 over 7. And doing that, you're going to get 3.04. So let me get rid of this. Okay. So let's continue. So that means our differential work done. So now that we've gotten this, we are going to be having minus 8 times 10 raised to the power minus 15. So if you add up what we are having in this square bracket, we are going to be having minus 17.53. So the next thing we have to do is to multiply minus 8 times 10 raised to the power minus 15 with minus 17.53. So if you should do that, if you should multiply it, you'll be getting 140.24 times 10 raised to the power minus 15. So this is negative sign here, this is negative sign here. So once you are multiplying them, it becomes positive. So that's why we are having 140.27 times 10 raised to the power minus 15. And don't forget the unit. So since it's also work done, differential work done, the unit will also be in joule. And this right here is the answer to the first part of the question. Exactly. So this is the final answer to the first part of the question. Now, in attending to the second part of the question, let's go back to it. Now you'll notice that what we are having here in the I part of the question is the opposite in terms of the polarity of what we are having in the B part. Now look here, we are having minus 6 over 7 here, and here we are just having plus 6 over 7. I hope you notice that. Here we are having plus 3 over 7, and here we are having minus 3 over 7. Here we are having plus 2 over 7, and here we are having minus 2 over 7. So you can see that it's more like saying they are in opposites of each other. So in that case, if you have to calculate the second part, which is the II, the Roman figure 2, your answer will be the negative of this, of what you have in the I part. So this, since in this one we got our answer to be plus 140, if you are to do the second part, our answer will be minus 140.24 times 10 raised to the power minus 15 joules, if you should do it. So that's what I want you to do, and then let me know what if you arrive at this answer. So let me know what if you arrive at this answer in the comment section. Now if you do your calculation and you discover that you are getting different answer, that's an indication that there is a mistake or there is an error somewhere in your calculation. Exactly, it's very important. Again, let me make mention of that because it will help you a lot if you come across questions like this where you are giving your AL. Remember I said your AL is the vector, the unit vector. Now if you are given something like such that for the first part of it, and then if you look at it with the second part, you can see that it's just the signs are in opposites of each other. Exactly. So here we are having positive, here there is, here you are having negative, here is positive, positive here, negative here, positive here, negative here, and you see that the values are the same thing, just the sign, they change the sign. Just note that your answer will be the opposite of each other. If you are getting plus 1 here, then you'll be getting minus 1 in the other side. So once you do your calculation and you are not getting the same value, such that if your question 1 or your I part, you got your answer to be 5 joules, just know that your second part is going to be minus 5 joules. So if you are getting anything outside the same value here, just know there's a mistake. So that is an indication that there's a mistake. Exactly. So like I said, do the second part, follow the same step, and let me know if you also got 140.24 times 10 raised to the power minus 5. So you might be getting something within the range of 140 points, points whatever, because of approximation. But just note that if you're having anything approximately 140, then you should know that you are correct. So thank you very much. I hope you find value in this. So in case you are still not getting it, I will encourage you to watch the video all over again. It's very simple and pretty straightforward. And then if you have any question or doubt, let me know in the comment section below. So with that, guys, I'll see you all in the next one.